Miss Jody here with another video for finishing up chapter 10. This video is on stars and groups. So stars will be grouped up, and then also stellar explosions, what we see in the grouping up of stars, and then what we think we see in the explosions that happen in space in that star world. All right, so again, for our videos, just so we don't forget, we want to keep taking all of our notes on a half sheet of paper and putting the title on the back so that we can glue them in when we return. Now with this, don't forget, little ones, you don't have to write all of these notes or anything like that. You can just write a word or two and draw me some pictures. That's totally fine. I'm okay with that. Doesn't have to be fancy. And some of the real little ones, you might not even want to do much of the notes, and I understand. It's not the same as being here at the center where we have the whiteboard and we can write out all of our stuff and draw pictures together. So it's a little more difficult. But I did want to keep the notes going so we get some learning done during this time. And we can fill in anything else that we didn't get finished, hopefully, with you little ones. So don't panic with little ones, okay? All right, so, but definitely for the older students, this is something you can do on your own and you can keep up with. So stars and groups. So let's look at that first. We'll look at stars and the groups that they make, and then the stellar explosions. So stars and groups, we have our stars, what we have called binary stars. And I got some little marbles so I could illustrate this, okay? So let's say if we have two stars in a system in which the two stars are bound together by gravity and they have their union. And so if we have these two stars in a binary system here, then they are going to be bound together. And there's a lot of binary stars, surprisingly, that actually are in their combination together. And like, say, for instance, I think our book, let me see, I think it tells us about Ceres. Yes. So Ceres is a set of binary stars. And so it's a system in which two stars are bound together by gravity. These two stars circle each other in the same way that the moon revolves around the earth. Sirius B orbits Sirius A. So if I have my two stars and I say this is Sirius A, and then we have this Sirius B orbiting, and they're locked by gravity and creating this binary situation. So that's two locked together. And then there's also what we call an optical double. The optical double is going to be a pair of stars that look close from our perspective, but are actually very far apart. So what it's basically saying is if we're looking up from the earth and we're looking up at the stars, it might look like these two stars from our perspective. Let me say, I got to be something really small here. What can I be? Let's say I'm this, this little crayon here. So this is Miss Jody. Super cute, right? So from my perspective, looking up, these stars might look like they are near each other, but in reality, because of just the angles and stuff, they're really actually very far apart, but they look like, it's like an optical illusion. And so from my perspective, that would be called an optical double. A pair of stars that look close, but are actually far apart in reality up in space. And then we have what's called a triple star. The triple star, that would be three stars all orbiting each other. So that would be a set of three. That one's kind of easy to remember, right? And if I got my marbles and grabbed another one, I could do, here's my three orbiting each other, so a triple star. And then you could have, I guess I'll bring my marbles over here, make it a little easier to grab. Then you could have even the next level, multiple stars. So multiple stars are more than three. So it's a group of stars and they're in a relationship and they are more than three. So a whole multiple star group. And then we could have what's called star clusters. These are stars grouping, and it's hard because my book is getting so big here. I'll move it up just so you can see. They're star groupings in a galaxy. So within a galaxy, we have these star groupings. And the star groupings get a little dark there. Let's see if I can get that. See if my light can turn a little bit better there for you. And so my star groupings in a galaxy, they can either, or my star clusters, they can either be open, and the open system is where they're kind of spread out a little bit, or really globular, where we got them real globbed together. So we have that, we see those clumps So they can be containing 10 to hundreds and occasionally thousands of stars in these open clusters. And in the globular clusters too, they would be tightly clumped together, spherical, they say. And sometimes they will travel outside of the boundaries of the galaxy. And so we have these clusters of our stars. With the star clusters, then we would have what we would call galaxies. And we're going to do a whole page on galaxies. So I'm just going to leave that for more extensive on another page so that we can see the different shapes of the galaxies. But that's a massive star system. Like we live in a galaxy where it's billions of stars and all kind of grouped together. So you see, we've got stars in groups, 2 together. We have 2 that look like they're together, but they're very apart. Then we have triple star, we got 3 together, multiple stars, 4, more than 3, so 4 or 5, whatever. Then we have clusters, groups of them together, either in an open cluster or globular, or then an entire galaxy. So stars seem to kind of go in groups. So that's pretty cool. And then with that, we have what's called stellar explosions. Now, stellar explosions are going to be when we see stars have some changes in luminosity and or an actual blow up and explode. So the first one is the nova. So if we've ever heard of a nova, not supernova, but just the nova. The nova is when a star suddenly flares up to many times its original brightness. So then all of a sudden you just have the star that you've already been tracking for a while, and then all of a sudden it just gets really, really bright. And there's some theories behind what might be happening with some of the extra burning of gases that make it to the surface and stuff. So there's lots of theories on why the novas do what they do. But basically, just as a simple way of viewing it, we just want to know that we want to remember that it's when it suddenly flares up and becomes a lot brighter. But in the end, it doesn't explode. Eventually it shrinks back down and ends up having its normal brightness. Okay. Then we have what's called the supernova. So the supernova is when the star actually explodes. And so when it explodes, we have a big massive catastrophe in space. And with that supernova, remember we did some supernova painting before we got separated, and we took those containers and we put the dry ice in the paint, and then we let them explode. And you can see at the Science Center my ceiling filled with all these paint cap marks from it exploding to the ceiling, and we have some good pictures of that. But this page is going right next to the stellar explosions because that was representing it. So when the star would explode, we talked about things that would be left over after that explosion. One of them being the nebula. What is a nebula? A cloud of interstellar gas and dust. So it's a big cloud left over in this process of the explosions. And then there's also something else left over, which we call the neutron star. The neutron star is the hot core of a star left over after a supernova. So once a supernova big explosion, you still have a little bit of it left. So you have the cloud of all this gas and all this dust, but you also have some of the star left over, like a hot core of it left over. And sometimes that core can be rotating rapidly, and that we would call a pulsar. So if you ever heard somebody say a pulsar, it's rapidly rotating neutron star. So here's a neutron star. That's what's left over after the big blow. And then we would have a spinning one. So if I was trying to illustrate this on my diagram, which we would have done if we were together, which you don't have to worry about this is already glued in your journal, but I would try to illustrate some leftover situation. And I guess this would have to be my nebula. All this gas up here is what I would guess would be my nebula. And then I'd have to make this my neutron star. Now, if I wanted it to be rotating really fast, I could do that and make it look like it's rotating real fast, and then I'd have to call it a pulsar. And so either I would keep it not rotating super fast, and that would just be my neutron star, or I could get it rapidly rotating and create a pulsar. And with that, I could add a bunch of little dust particles, because in that explosion, and I'm just going to put them with like some little glue here to add some little sparkles to this guy here. I'm going to put some dust particles in the leftover gas here that we've created. Again, this is not something you have to do because you don't have this page, but when we come back together, depending on how much crafts and stuff we have to do and science experiments, we don't have to do this, but just for illustration purposes, I'm putting a little bit of that glitter on my leftover nebula there. All right, so that would have been a cool project that we could have done. I'll shake a little of that off there. And then go to our last page for this video, and I'm gonna have to get me a little plastic baggie like we do sometimes to keep all of the stuff from sticking when I turn the pages. Remember, we do that when we're doing stuff inside of our journal. Since I have glue on there, I've got to stick that baggie in there. All right, and then the last part of this, which goes along with stars and groups, is I thought it'd be good for us to look at the way the stars can be grouped in their galaxies. And so galaxy is, remember, a massive star system. Now, I wrote this on the side here. Now, it's already written on our notes over there, but for some of you bigger kids who like to take more notes, you could just turn your little diagram sideways and write a few of these things on here. Galaxy, a massive star system. And in the star system, you can have millions to billions of stars. So in one galaxy, you have millions to billions of stars. And in some galaxies, a lot of gas and dust. Some don't have as much gas and dust. And it's thought, and I turn this back up and down here, it's thought that there are about 120 million galaxies as we're studying galaxies. So we're talking about a lot of galaxies, and then in each galaxy, millions to billions of stars. So our universe is so vast. And you remember when we watched that video when we started this unit, and we saw how big all these things were and how far away they are. And we talked about the solar system and getting to even just the planets, and let alone getting out of the solar system. And say, for instance, like this particular galaxy, so if I said this was the Milky Way, and I would say we're just one little tiny solar system on this whole big, huge, giant Milky Way. And so how big this must be with 100 or with 1 million to billion stars, and then not only one galaxy, but 120 billion galaxies. It's unfathomable. Our minds can't understand that amount of size and that amount of stars and that amount of galaxies. We can't even understand it. And the fact is, we've only explored just as far as we've gotten in space, which is not very far, right? In our little tiny solar system. So it's amazing. All right, so with that 120 billion galaxies, even the galaxies can be grouped up. So they can be grouped up in clusters, and in those clusters we have our little local group. So we have like a little local group in our cluster where our Milky Way is. Or you can have big super clusters. There was a whole bunch of those clusters together and real big. And so then you see that even the galaxies are gathered together. So it's this vast system. It's very fascinating. And I'll send you some videos on that. All right, but in this galaxy world, we got 4 of these main ones that we always talk about, but there's actually more. There's the peculiar, there's a lenticular, but I'm just giving us some of the main ones. So you've all heard of a spiral galaxy. That one's kind of easy. We always think of the spiral, and we think of the center, and then we think of the spinning outward around it, right? So that's going to be my illustration. I'm just using a little bit of glue, and I'm using a little bit of my stars here with my silver glitter. Couldn't find my gold, but that'll work. All right. Get some of that off there. And then, and this is, again, this is not something you have to do if you don't have glitter at home. This is just me trying to make my journal look a little better. You can just do this with a coloring marker or something like that so you can see the pattern. So the spiral galaxies, there's a central nucleus that resembles a flattened ball to which it are attached long curved arms, so it kind of spirals around. So that's just a regular spiral galaxy. There's also the barred spiral galaxies, which is still a part of a spiral galaxy. But what's different with the barred ones, the spiral arms attach to a straight, which looks like a bar that runs through the nucleus. So with these guys, it looks like there's like a line here. There's still that center, that nucleus, but there's sort of a line, and then you've got the arms spiraling around. And so scientists think that we live in a barred spiral galaxy, the Milky Way. It's kind of hard because some people say we live in just a spiral. It's hard to tell because we can't get out of our solar system yet to even take a picture of our solar system, let alone our actual whole galaxy with all these million to billion stars, right? So, it's hard to tell. But most people think we're a barred galaxy. And then the elliptical galaxy, that would be still a grouping of stars, but they say it resembles like an egg or a football. Not as structured and does not contain as much free gas and dust like some of the other galaxies. So if you see, I'm going to put a little dot in the middle. That's going to be the, oops, that wasn't very good, right? That's going to be the center of my egg. Like think of an egg and its yolk, and I'm frying my egg here, and then this will be just like around it. A little haze of stars. So it's not as spread out and looks kind of like, now when they say an egg or a football, if it's stretched out more, like we talked about when we were learning about Kepler's laws of planetary motion, and we said if you're more stretched out, you're more elliptical. So the more stretched out this gets, it would look like a football, right? So if I wanted to create a football looking one, I'd stretch him out just a tad bit, but not necessarily making him spirally looking, but making him more football-y looking. But still, this is a galaxy that's not very structured, and it doesn't have as much free gas and dust. And then we have the irregular galaxy. Now these are galaxies that stars are clumped together into no definite shape. So there's not like a special shape or pattern. We just have these stars, they're clumped together, so it's a galaxy, but they're just kind of all around, and you don't see that same kind of feeling of the rest of them that are spiraling around, or at least have this pattern. And so it's pretty irregular. So I just dumped a little bit of glue on that and put a little glitter on there. And so that's the way of looking at our galaxies to help us a little bit with understanding the galaxy shapes. Now with the galaxies, there's also what we call quasars, and this might be a little hard to see down here, especially now they got a little bit of glitter on there. But if any of these are hard terms for you to see on the notes, they're also in the book, and they're always highlighted. So as you go along, if you can't see or my handwriting's bad or something, you can just find the actual definition inside the book. But quasars are extremely bright areas that are at the center of galaxies. So if you ever look at a galaxy picture, you know how it's really bright in the middle, and you're like, what is that? And people always say, oh, there's a black hole in the middle of the galaxies, and we think that there are. Well, that's what's with the quasar world. So the idea is that the center of that black hole, that in the middle, and then all of that being that dense packed area, pulling everything in to that area, would be igniting what would it be, like the matter involved around it, and creating this really bright glow. And so as a technical definition, it says the quasar is an extremely bright object that emits both visible light and radio waves. Quasars are some of the brightest known objects in the universe. However, they are believed to be small for their brightness, probably not more than a few light days across. And of course, you know what a light day is, the distance that light can travel in a day, which is 16 billion miles. That's pretty far. They're usually located at the center of galaxies. Scientists believe that each quasar is made of a large black hole surrounded by a glowing ring of gas called an accretion disk. The gravitational pull of the black hole compresses the accretion disk, causing the gas to heat up, and then the gas at the disk heats up so much that it glows extremely bright. So if I wanted to give an idea of these quasars, I'd have to kind of open up this little area I'm doing with my pencil to try to create this black hole. If this is true, and again, we don't know for sure how all these, with these galaxies, because we can barely see anything too far, and we're trying. We did have some data that came from a scientist or an amateur that was visualizing a black hole, and so we do think that they do exist. There's a lot of physics that say they do. I'm trying to make the centers here with my glue here. It's going to be a little hard. So that would be my center, the black hole, and then everything around it would be superheated in that process of that movement. And so it would just spit out all this really bright light. And so if you look at galaxies, they're always really bright in the middle. So to illustrate that, I have this page. Now this is something you can do at home if you want to, either with markers or crayons or glitter if you have any. I'm going to try to create the idea of the quasar in the middle or the black hole in the middle, and then the brightness ring around it. I'm going to attempt, right? So, and then I'm going to create my galaxy. So I'm going to try to get my black hole here in the middle. And this you could just do on a regular piece of paper or colored sheet. I actually already had this blue glued in there, and so I thought I'd just use that one. And so there would be my black hole. And then I'm going to put some stuff around it, this disc here. That would be the part of that quasar. That would be that really brightness kind of igniting there so much. And that would be my really bright glitter here. And again, if you have glitter, don't go out the store to get all this stuff. This is just if you have it, or you do it however you want. Be super creative. And send me pictures. I miss seeing you guys, and I'd like to print out some pictures of you doing schoolwork. Send them to me in the Google Classroom. You can attach them right there, and I can print those out, and then we can have some pictures for your journals, even though we're separated. All right, so that would be my center, and then I'm going to just start creating the rest of my galaxy. I'm going to create a spiral, which would be just billions, right? Millions and billions of stars. I'm going to get my good galaxy. I don't know, do I want to make it kind of spread out a little bit? Because even the spiral galaxies can spread out a little bit and start taking on a little shape of arms. So let me do that here. Do I want to keep it with the silver? I think what I might do, no, I probably better keep it with silver, just to represent all the brilliance of those stars. Maybe I'll throw a little of this gold in here, but let me get the most of it in the silver. So I'm going to put my silver on there. That's going to be my little galaxy. And then I might add a little bit of this little, just to really bring it up there. Okay, so this is apparently my addiction of glitter and not being able to use glitter for a while. All of a sudden I'm doing 2 videos with glitter. All right, so that, and if I shook it off, it would be really nice galaxy, and tons, and representing tons and tons of stars. But I'm going to leave it there to dry so a lot of those good pieces get on that glue there, so it looks real nice. All right, so that's the end of that one, and I'll see you next time.